Hello everyone and welcome to today's webinar, Get a Piece of the Database as a Service Action. My name is Jack Allen and I will be your moderator today. Joining us are Sandeep Patney and Chip Childers. Sandeep Patney is the co-founder and vice president of systems and engineering at Cumalogic. Prior to Cumalogic, he has spent more than 11 years at Goldman Sachs in various infrastructure roles and as an application infrastructure architect for risk technology. Chip Childers is the vice president of product strategy at Cumalogic. Chip's previous role was as chief architect of SunGard's cloud service offerings. He also served as the first vice president of Apache Cloud Stack for the Apache Software Foundation. Throughout our presentation, we encourage you to submit questions using the questions pane on GoToWebinar. We will answer questions live at the end of the presentation. Please keep in mind that all participants are in listen-only mode. We are recording today's session and will email a link to the recording tomorrow and post links on the Cumalogic website. With that, I will turn it over to Chip.
All right, thank you, Jack. Appreciate it. Okay, so let's go over the agenda for what we're going to cover today. We're going to do this in 4 sections. First, what we're going to do is spend a little bit of time talking about the database as a service market opportunity for service providers. Then we'll spend a little bit of time looking at the architecture and doing a feature review using our presentation. Then I'll hand off to Sandeep, and he's going to give you a live demonstration of the system and let you take a look at what the user experience is like. And then we'll pause and we'll take questions. I think, as Jack said, everybody's on mute right now, but if you use the control panel, you could send in questions over the course of the presentation and the demo, and we'll review those at the end of the webinar. So, obviously, today's webinar is focused on service providers, and what we want to do is share a little bit of information with you about the overall database as a service market, some of the trends we're seeing in customers of our service provider customers, as well as in the enterprises that we speak to directly, and of course, generally how the market's looking with regard to database as a service growth. One of the better reports that we found is a report by 451 Research. They put this out, I believe, in about 2013, and what they did was they took a look at the adoption of database as a service across all the enterprises that they surveyed. And what they found is that in 2013, about 30%, a little bit higher than 30% of enterprises were actually using some type of database as a service offering. And this is focused on the relational database services like Amazon's RDS. But based on the growth trends, they saw it growing to 2016, over 70% of enterprises would be adopting it. Now that's very significant growth. That's a 100% year-over-year growth over the next few years. And what's interesting about this is that it's when you speak with customers, it's rapidly becoming almost expected that their cloud providers are going to offer this type of service, because Amazon, Google, Microsoft, all of the largest public cloud providers are offering not just virtual machines and object storage, but database services are a key part of their service portfolio. And so it's expected by developers that they don't have to configure databases on their own. They can just simply ask for a database instance or a cluster and know that it will be managed by the provider. So very impressive growth, and that presents an opportunity for you as a service provider to make sure that you attract those types of users and also retain the users that you have today. One of the questions we get frequently is about why do customers actually want database as a service functionality? And really it kind of boils down to 4 major issues for them. First of all, within the enterprise, application-specific databases are proliferating. And the reason for this is that the total number of applications is growing dramatically. Every little nook and cranny of the lines of business are developing point solution applications. They're getting consultants to come in and build them, sales enablement tools, marketing front ends, internal line of business operational tools. Each one of those new apps typically has at least one database, plus it'll connect to systems of record. The second trend is that there's a massive growth in overall stored data. Third, increased velocity of change in the application layer. You're seeing this as agile methodologies for development have, not only are they being adopted, but they're really becoming the standard operating procedure for app teams. And then the DevOps style practices for how to operate and how to rapidly iterate the application changes and get them all the way out into production are causing a velocity and change that's something we really haven't seen before in the industry. And the fourth issue is that there's challenges in operationally supporting newer technologies. You think about your traditional DBA teams, they tend to focus on systems like Oracle or Microsoft SQL Server. Very infrequently, although certainly they're out there, but a lot less frequently, you see DBA teams having the skills to operate something like MongoDB or Couchbase. And so these newer technologies present some hurdles for the IT operations group. As developers demand new technology, they're not necessarily sure how to deal with it. So this is where database as a service becomes very useful. And you as a service provider can take advantage of some of these challenges that your customers are having and offer them solutions that solve a lot of the issues for them. The other question that gets asked is, what exactly are the use cases for database as a service? And I think that it should be fairly obvious when you understand that development and test is very frequently what databases are being created for within the DBaaS platforms out there. But production web applications, and so of course you're doing a lot of development and test, and very frequently that's then becomes a production system. Once you rely on the services offered during your dev and test cycle, you can expect that production is going to have that same level of service. And then there's a few more. There's additional capacity. There's the use around analytics or business intelligence functions. There's backup and as well as departmental apps. So really, there's a variety of application use cases where the developers are looking for database as a service. And again, at a macro level, the enterprise is struggling with those four key challenges of growth in data, number of databases, change, as well as new technology. So given that, what Cumulogic has done in our Falcon release, which is our latest release of our software, is that we've really taken our modular services message and we've honed it in, and we've said database as a service is really going to be our core focus. And the concept that we have for this is that we sort of look at Starbucks as a good analogy. If you go into Starbucks, you can order a large number of different types of caffeinated beverages. And it's anything from soy mocha lattes through a simple cup of coffee. But they've made the complexity of choice very easy. And you can walk in and you really just have to give them an idea of whether you want a certain type of caffeinated beverage, what additional flavoring you might want to add to it, what size or what container you want to bring in to have it poured into, and then you're good. And so we want to do the same thing with database as a service for you. Your customers should be able to come to you and very simplistically say, this is the database type that I want. Let's say I'd like a Couchbase SQL cluster. I'd like it to be large instances. I want to make sure that I've tuned it appropriately, so I'm going to pick a particular configuration that's going to tune it for read intensive, and then I'll pick the infrastructure that I want to run it on. Now, in most service provider environments, that infrastructure is going to be yours, but Cumulogic can support use cases that you might find interesting as a provider where you have multiple pools of infrastructure. Some might be your production grade infrastructure as a service environment. You might be offering private cloud environments to your users. You can bring them all together into the Cumulogic environment and have a consistent database experience regardless of the infrastructure that you're letting your customers target. So for service providers, we really think that the value of our software is that, one, you can enter the database as a service market very quickly, and that's going to get you new high-value recurring revenue. It's also going to help you protect revenue that you have today, because as developers mature, as they explore other services, they're going to find that database as a service is being offered more and more. That might make competitors more attractive to them. So it's also revenue protection for you. Second, applications are going to live close to the data. That means that you're going to see an increase in service consumption across your portfolio of services if you have that data in-house. There's a notion of data gravity here, where the more data that you have in your environment, the more likely it is that you'll attract, one, more additional data, and two, the applications will be pulled closer and closer to your infrastructure, if not being run on your infrastructure. And the third is that database as a service, again, is rapidly being required. And so when people might be putting out RFPs, or they're just simply browsing around for an appropriate cloud service provider, they're looking for database as a service to be part of the service catalog that's offered to them. So I mentioned earlier that we've released our Falcon release. Our previous platform version was codenamed Eagle. The Falcon release is where we're really focusing on this notion of data services. If you have experienced our product in the past, some significant changes have been made around the user interface, as well as the API. The API has really been cleaned up in terms of its syntax and its clarity. And the UI is really fresh, very modern, great look and feel. You're going to get to see that in the demo. Third, we've had a significant maturation in the core architecture. We're able to scale horizontally at the controller level very cleanly. We've got a good plug-in model for extensions to the platform. And we've added some enhanced orchestration capabilities to tie into external services, like, for example, Mongo's MMS platform. We have App Dynamic, New Relic integrations. And so that's maturation of that core architecture. And then fourth, the database as a service functionality that we had in our past platform was ported over to the new version of the platform. But more importantly, we've been working with a number of our customers to really harden and enhance the functionality that we offer. So you'll see improvements in both our relational database as a service, as well as significant improvement around both MongoDB and Couchbase functionality. We've partnered with both of those companies, spent time doing technical reviews with them, and taken a lot of their best practices and applied them to how we automate and orchestrate and really deliver Mongo and Couchbase clusters for your users. So this is the general architecture of our database as a service platform. Kind of looking at it top down, we have a customer console, which is what you'll see today. There's an equivalent admin console, which is what you and your operations team would use to manage the Cumulogix services. And then we have those core data service automation functions, clustering, sharding, monitoring and self-healing, access control, backups, restores, and then an AWS-compatible API support if you choose to offer that. Below that, we have our engine plugins, as we call them. Right now, we support MySQL, Percona, MongoDB, and Couchbase. I'll get to some of the future engines that we'll support as we drill in a little bit more. And then last, we talk about kind of the infrastructure that's underneath all of this. Again, our controller can work with any number of infrastructure as a service platforms. We can work with pools of pre-provisioned systems, be they virtual machines or bare metal. We can also enable use cases for service providers where you might choose to offer production systems with very high SLAs and high support contracts living on your infrastructure, but you might want to resell Amazon's infrastructure for the purpose of dev and test. That's an option that we can enable for you. Again, you'll have a consistent experience for your users when it comes to databases across those platforms. So what we'll do next is we're going to dig into the two high-level modules of the platform. The first one is the relational database service. Then we'll hit the NoSQL services. So first, a relational database service. This is really designed to mimic Amazon RDS. What that means is that it's a software, our controller is a software platform that lets you deliver fully managed relational database as a service. And specifically, we support MySQL as well as the Percona ExtraDB engine. If you're not familiar with that, it's a slightly different operational characteristics, but it looks and feels like MySQL from a developer standpoint. We're working to integrate both Oracle as well as Microsoft SQL Server support into this module. The features will be very similar to what we'll show for MySQL and Percona for both Oracle and Microsoft SQL Server. There's slight variation between the engines based on what they're able to support in terms of highly available architectures or replication topologies. But what we want to do is allow a consistent experience and then let some of the features of the individual engines shine through, which is why a developer might choose one over the other. Specific features that we're supporting today include highly available architectures. We'll look at a couple of use cases we have for that. Example deployment architectures we can support. We are both data center or region and zone aware. So depending on the architecture of the infrastructure underneath, we may be talking about, again, pools of pre-provisioned systems, or if you've got an IaaS stack, we'll be talking about things like regions and availability zones. We do automated backups, point-in-time restorations, or restorations based on a snapshot. Our platform will maintain telemetry into the deployed instances on behalf of your users that will provide both performance metrics as well as health checks. And we'll do fully automated failure recovery. If a node in a cluster goes offline for whatever reason, our controller will bring a new node online, rejoin it to the cluster, and restore resiliency to the environment. We do things like database cloning, rollback, point-in-time data provisioning. All of those are supported as self-service functions, either via our console or through our API. And last, the user needs some access to the logs that are being generated on the database nodes themselves. Again, they can get access to things like the slow query log, audits, access logs. That's transparency that's necessary for them to work with the database, but yet hand off the operational support to you, and you're delivering it via the Cumulogix software. So some example deployment scenarios. Taking a look at what we can do with MySQL. MySQL is very good at allowing for read replica topologies, and so the way that we work with, the way that users work with the MySQL engine is that they'll deploy a single read-write node, and then as they want to scale horizontally, typically for web applications, they need more read capacity. They add additional read replicas. And those replicas could be deployed to the same zone as the read-write instance, or they could be deployed to secondary zones. Any read replica that can then be promoted to being a read-write replica, a read-write instance. It gets disconnected from the initial read-write master. It becomes a master itself. Great use case for this is your end user has a new release of their software that they're going to put out there. What they might choose to do just prior to releasing is that they'll create a read replica that they're intending to use once replication's caught up as a way to smoke test the application as one last check using production data before they do the cutover to the new environment. So it's easy for them to say, hey, create a read replica. Once replication's caught up, promote now to being read-write, point the stage version of the application to that read-write, and go through their testing process. With Percona, it works a little bit differently. Everything's read-write, and so we're able to deploy multi-node Percona clusters. Those Percona clusters can be deployed, again, very similarly. It allows you to scale out. You can grow these clusters using our controller, and you can also span multiple availability zones with it. One feature that we've implemented, if you have multiple availability zones within your cloud infrastructure, so multiple data centers, we can let end users take advantage of the multi-zone replication with automated failover. And we do this via DNS services. So the application would connect to the primary zone, the read-write master that's sitting in the primary zone, and they connect to it via a DNS hostname. Now, the Cumulogix controller will take care of deploying a secondary or standby master, creating that replication scheme, and managing that replication to make sure that it stays healthy. Now, if our controller identifies an outage in the primary location, it could just be a local node failure, or it could be a full DC outage if one happened to occur. We'd initiate a DNS endpoint failover. That means that the application gets redirected. You also notice that we've cut off the replication between the nodes. So the application's now working with the secondary location. Once we're able to reestablish connectivity, we'll recreate a new recovered node. We'll establish it as standby, and then create the master-master replication process again. So that restores resiliency to the architecture. The other thing we can do, of course, is depending on how the Cumulogix controller is deployed, we recommend that controller sits in an isolated infrastructure fault domain from where it's actually deploying databases. And that's important because that's how we're going to store the backups, and it's how an end user will be able to potentially if they didn't subscribe to that automated failover, take a backup, take a snapshot, and recreate an instance perhaps in a tertiary fault domain, so a second availability zone, and they could self-recover in the event of a big disaster. So that's a relational service. Let's very quickly hit the NoSQL service, and then we'll hand off to Sandeep from the demo. The NoSQL service is designed in a way that's very similar to the relational services, but because NoSQL engines have a slightly different operational characteristics, end users want different features from them, we've separated out the module. We support MongoDB and Couchbase today. We are, again, designing it in a way that's similar to Amazon's RDS functionality, except, of course, these are not relational databases. These are document stores. But really, if we drill into MongoDB, we've spent a lot of time working with both Mongo and Couchbase, but just focus on Mongo. We've gotten the operational support effort that's required for very complex Mongo deployments down to almost zero manual operations. An end user can use the Cumologic controller, and they can request anything from a single node Mongo instance, which is very easy to do. They could also then say, oh, we want a multi-node replica set. But more importantly, and I'll show this in a slide in a few moments here, we can also deploy sharded infrastructures. The sharded infrastructure is a bit more complex with Mongo. It involves query routers up front to understand the sharding scheme and pass traffic down to the appropriate shard. It requires configuration servers to maintain the config of the entire environment. And then each shard might be a single node MongoDB instance, or it could be a replica set in and of itself for high availability purposes. Elasticity is very important when you're deploying something like MongoDB. So we can grow the number of replica nodes within a replica set. You can easily grow the number of shards in an environment. We allow for the management of the collections within Mongo, so that for each collection you're very clear about what's being deployed. That's important as the sharding occurs, because you're going to need to make sure you identify things like what the attribute that's going to be the shard key is. And we'll get into that a little bit when we show the demo. All the same types of backup, monitoring, profiling, log access, automated health recovery, all of those features that we talked about with the relational service also apply to our NoSQL service. Quickly, some example deployment patterns. Here's MongoDB. This is a simple 3-node replica set. Obviously, we have one primary, 2 secondaries. Easily adding nodes. You can easily add nodes for additional scalability there. You could add nodes for redundancy and span zones. And now this is the architecture that we make just as easy to get access to for the users as a single node instance. And this is a production sharded deployment with 3 shards. So again, this is literally a drop-down and a couple of checkboxes on our UI in order to get this level of complexity deployed on the user's behalf. And we manage it all for them. So with that, what I'm going to do is hand off control to Sandeep and let him walk you through a demonstration.
All right. Thank you, Chip. Hello, everyone. I'm Sandeep Patni, co-founder and VP of Systems at Cumologic. In this part of the webinar, I will show you how easy it is to set up and manage database as a service with Cumologic. So what you are seeing here, this is the Cumologic user interface, the Cumologic user dashboard, as Chip called this, as the user console. When the user log in, they would come to this screen. From here, they can get a view into their SQL and NoSQL services. By now, you know that Cumologic provides SQL and NoSQL database services on any IaaS infrastructure. Now, users can launch a dedicated MySQL or a MongoDB service and optimize that for a particular workload as needed. So Cumologic allows you to provision and manage databases from either this user interface, and also we have the RESTful APIs available. You can make use of those RESTful APIs and configure that on if you have your own user dashboard or portal. From there, you could make those calls and provide the same functionality without leaving your user screen from there having a single sign-on configuration done between QMlogic and your environment. Now, before I go into start provisioning a database and showing you some of the other features on that one, let me just quickly point out. So when a user is using QMlogic service on your infrastructure, they would need to add what we call as target cloud. So target cloud is nothing but the credentials for their IaaS infrastructure. For example, you can see here I have here you can add the target cloud, and I have some cloud added here, which is my Amazon EC2 account at this point. So here I have provided my credential information. So when a user once the information is provided, any infrastructure, any provisioning or the storage or the virtual machine that is being done is going to be done using these credentials into that that particular target cloud. You can obviously have more than one target cloud, like Chip pointed. You could have, and user can choose during the deployment, as we will see quickly how the user can select that. Going back to the dashboard, now let's see how easily we can provision services. Let's go first into SQL database, and then we'll jump into NoSQL and walk through some of the scenarios there as well. So this is the SQL service dashboard. Under the click on the instances, you can see here the instances. So this is my current instances which are running in the account. That's my dashboard here. Let's go first into the launch instance. Launch instance basically would come up with this friendly the screen, which you have to just fill up some of the information. You answer these questions. This is basically what that Starbucks menu Chip was talking about earlier, where you pick and choose what engine you want, what size of instance, and so on. So let's take a look. Name your database instance. So I'm going to call it, let's say, DemoDB5. I can give it some description. Then choose the engine. So from the available two engines in the SQL service, as you know, we have MySQL and we have Percona-as-a-Service cluster available. So I'm going to pick Percona here. Then I can pick target cloud. So like I mentioned, if you have more than one target cloud defined, you could pick that from the screen here. So I pick that. If there's only one, that's by default, and that gets selected automatically. Similarly, for availability zone, you can, if you have more than one availability zone, you could that would become available here for that given target cloud, and you can choose that. Then you choose the size of your instance. So in my case, for example, I have provided a choice to the users to choose a micro or a small instance, and I can pick one of them from here. Now, since I have selected the Percona-as-a-Service cluster, as the name says, this is a cluster. So you can see here at the bottom, the number of nodes has already become 3. Now, while provisioning, the minimum requirement for the cluster is 3. It's using the Galera libraries, Galera replication for doing the master replication. Now, you can increase the number of nodes by simply, adding number of nodes from here, or go with the default minimum. You can always add more nodes. I'll show you on one of the provisioned nodes how to add nodes to an existing running cluster. It can be scaled up. So you can start off with 3 and then grow from there. Now, also in the Percona, the other configuration which Chip pointed out was the multi-availability zone support. So if you have more than one zone, you can provision across the zone failover capable database. Now, even if I have a single zone here, I can still make automatic failover scenario available within that same zone. So I check here on the multi-AZ support. Then I choose the secondary zone. Now, if I had another zone, of course, that will become available, and I can choose that from here. Then I choose my instance size for that secondary node. I give a service tag. This is just identifier for your database. I'm just going to call this as a production database. Now, in the access group, so access group is basically the firewall access control for your database. So you can control who gets access to your database. Now, if you have some pre-created access group, you could use that for all your databases, so that while provisioning you define that once, and all your databases have the same access firewall configurations. Or you could just let the system create a default firewall configuration, and then you could always edit that. I'll show you how you can add and remove access for particular IP addresses or range of IPs and so on for your application. Now, at the bottom section is basically the database configuration. So I have some predefined database configuration here, the username, password you could choose, and so on. You can define what port you want to run this on, and so on. Now click on continue. go to the next screen. Now here we have parameter group, so you can define the performance characteristics here. So in the parameter group, similar to the access group, if you have something pre-created, you could select that, or if not, then you could let the system provision that with the default parameter configurations, and you can always fine-tune that, or once you look at your application, once you let it run for a certain time, you have better idea about how that database needs to be fine-tuned. So you can always go back and apply the parameter groups later on a running database. So we'll just let it get created with the default one. Here you define the size of your database. So you can this size you give here in gigabytes. I'm going to start with, let's say, 5 GB of my database. That's it. So in the bottom, these are the other optional functions which are available. I could enable backup. So this is basically defined enabling the automated scheduled system backup, and then you can choose default retention time is 1 day, but you could say set that to the higher retention time so that the 5 days worth of backup would be kept around for you to restore and so on. Also, you can define your backup start time and so on. Similarly, you can define your maintenance window, or if you wanted to be your database to be SSL enabled, you could do it from here. By the way, all of these functionality, like I said, for parameter group, for access group, for enabling, disabling backup, maintenance, and all of that, this is all available as a choice later. So if you're not sure at the time when you're provisioning it, you could always go back and modify that state of the configuration. So that's it. We have provided all this information. Click on submit. Now this just gives me my summary information. Like in Starbucks, when you order, the waiter there would tell you, okay, this is what you have ordered. Are you sure? Confirm that or whatever. And then so you have that summary here. Now you go and say subscribe. If you wanted to make a change, click on back and go back and make the changes. Once I'm ready, click on subscribe. So that's it. Now that instance provisioning has started. So what is happening, you would see here that DemoDB5, which we just launched, is now showing here in the building state. In the events tab here at the bottom, it is showing that now the instance creation has started because we selected the multi-AZ deployment. So there will be one primary and one secondary node that is getting created as hot standby on that. So those two instances are getting created. Now, the architecture, the MySQL architecture you choose, that will impact your performance and the availability and data durability characteristics. So for example, if you selected a standalone or a replica set, that will provide you the read-only capacity, and while the cluster will give you the high availability scenarios and so on, and while the multi-AZ deployment, which we just did here, will provide you across the zone availability and so on. Now, as this database is getting provisioned, just want to point out that we have seen all the configuration options which are given for provisioning that database. So not only the initial configuration and the provisioning is automated, but we have automated the other performance optimization, backup, security, and access control and so on, all those administrative tasks, and making it like almost like zero operations, so that you can the user who's using the database can focus on their application and use of the database rather than worrying about all those administration. And then for you as a service provider, this makes it easy for your operational staff to being able to manage that database with all these automated functionalities. Now, while this is getting provisioned, let's take a look at some of the existing database which I have pre-provisioned for the purpose of this demo. So in the event tab will show me all the events on there. The access details, the bottom section here is basically all the information about my database for me to be able to access. So access details gives me access information, my username, password, and also it also provides me, like, if my IaaS supports private public IP addresses and so on. So it gives me all that information for me to be able to connect to the database. And my username and password, which I selected during provisioning, is available here for me to connect. Similarly, there is usage metrics, which will tell me how my database is being used. So I have a database instance created, some data is loaded, and how much space is remaining, and so on. Logs will I can choose from here what kind of logs I'm looking for. I'm just looking for MySQL log or on a particular host. If there are more than one, that will be listed here, and then I can go through this log, or I can also look at my slow query log or general query log for profiling my database and so on. Now, so this is all basically the read-only information or the information about my database for access, for log, and for usage metrics and so on. Now, some of the administration functions which I would like to perform on my database, now those are all available here. Like you can see, during provisioning, we selected the automated backup. So here, so that automated backup will be functioning at that scheduled interval, and it will be taken automatically. But there are use cases when you have, let's say you're making a major change in your database and you would like to take a snapshot of the database just before you make that change, so that you have at least the option for you to be able to restore back from that state and so on. So you could always do a manual create snapshot on a particular database instance, choose that database, and give it a name and take a snapshot. Once you have taken that snapshot, of course, there's two options available. One for you to be able to restore from that particular snapshot, or also you could do a point-in-time restore. That basically means you could actually select a particular time interval when you want your database to be restored granularly. So other than the backup and taking backup and restoring it, now all the other actions which are available are made available here under the actions tab. Here you can see I'm going to click on that, and I'm going to walk through some of these actions and show you. So here we have I can add replica. So like I said, I provisioned that initial instance as a standalone MySQL instance. Now I wanted to add more capacity to it, so I could just simply click on read replica, select information where I want to select it. Like I said, you could provision that into another zone if that's available. You could provision a different size of the replica, and you could, of course, provision a replica with bigger storage size. So now the scenario which Chip pointed out, where you wanted to create a snapshot or replica of a current database, you could always choose a larger database size, larger storage size, and of course a different zone, and then promote that replica to be used as an independent node for your new application and so on. So without you having to take backup and manually copy it over to the other, set up a new instance and then copy it over and so on. So that's taken out. Some of the other actions, mostly self-explanatory here. You could terminate the instance, you could restart, clone the instance. Now here under modify, you can see, like I mentioned, during the provisioning you selected certain options, but if you wanted to change it, for example, I selected the retention period as 1, I wanted to change it, or change my backup start time. Also, I didn't enable maintenance window, so now I can configure that maintenance window from here and set that up. I selected this instance without a parameter group. Maybe I want to enable a parameter group, so I select that from here. Instance type, this is a new function we have added, where you started off the database as a small or micro instance, but over the time now your need has grown and now you want to grow that database in place. So provided that the underlying IaaS provides this functionality to change the instance type and add more capacity to your instance. Like storage capacity can be added separately, but most IaaS would also have the functionality to provide you the additional CPU and memory that can be grown from here. So that functionality is used here, and I could start with a small instance and grow to a larger instance without me having to redeploy the whole database and whole 9 yards from there. So I selected that. I could apply these changes right now, or I could just modify it so that it gets applied in the next maintenance window and so on. So I could just click on apply and let that changes apply right now to the database. Also, some of the other actions, you can add storage, enable SSL. So we have added the functionality for SSL, like we saw during the provisioning. You could enable SSL. If not, then you could always go back to that instance and then enable SSL on that. On the Percona cluster, so this is running with the 3 nodes right now. I could go and add more nodes capacity. So there's a function for adding nodes. So like I said, you could start with 3 nodes and then scale, making it depending on your application requirement. So it basically gives the control in your hand to not having to pre-provision all of that additional capacity which you think you might need in the future. You could always grow and shrink the nodes right from here. One other functionality here is to configure thresholds. Now, there is a lot of the functionality is automated. System is taking care of the backup, the monitoring, also, the automatic service recovery, and even the virtual machine recovery and so on. But there are scenarios when you would like to know how your database is doing, so you could always set up some thresholds of your own for CPU, memory utilization, the storage, and so on, and set up certain rules, like once every 3 times this condition is met within 5 minutes window or something, then you want to get emailed out. So this that information will be sent out to the registered email address automatically. So then let's say if you run out of storage, then you could always go back to that instance and say add more storage to it and so on. So that's so this instance is still getting provisioned here. Now let's go and see some of the other functionality which is available here on the left hand side. Like we talked about, replicas can be added. So I have a replica which I have pre-provisioned here, which is added there. Now, similarly, access information, read-only access is available to that. I can also go and see promote that replica as a master or terminate that replica. So on the replica, basically, there's I can promote this and make this as a standalone master of its own and start using that for my new application. In the snapshot, it will show you all the snapshots. You could always restore from that snapshot or delete that to conserve space once you are done with using it. Monitoring, this would show, like the name says, the monitoring information. I could click on a particular instance which is running and look at the monitoring, all the standard performance metrics available for that instance, and I can dig deeper. I could click on that and see for the last 2 hours or even go up to last 24 hours window and so on to see the performance data. Briefly, just want to show you here the parameter groups. The parameter groups, you can create a parameter group as many as you need, or you could just use a single parameter group for all of your database instances and so on. For the particular, let's say for a particular family, we call it like that engine, MySQL or Percona and so on, that would be available. And the parameters are listed here. You could edit those parameters, set a new value, save it, and apply that to the database for fine tuning. In the access group, similar to that, you would have the rules which are defined. These are the default rules, for example, for that node. Now you would have only this port open. We have kept it open for all for now. You could always go and edit this particular rule and say you want to allow this access only to particular IP range or so on from here. And if you wanted to add more particular IP address rules, you could go from here and add them into that. Now these rules will be automatically updated and applied to that service, and you would be able to see them right away, the access control on that. So that is basically the SQL database as a service. Now, NoSQL service is similar in many aspects from here. All the functionality, all the bells and whistles you see here are available in the NoSQL service. Click on the NoSQL, click on the cluster, and now you can see I have provisioned some instances. I would just walk through some of the standard configurations which Chip showed in the during the presentation. So click on the launch cluster. Let's just walk through some of the configurations here. Give it some name, description, engine. Similarly, we select what you want to provision. So I selected Mongo here. Then I can select the type, like I want to provision a standalone single node, or I want to provision a replica set or a sharded cluster. So depending on that, the number of nodes will change. For example, if I take the replica set, the number of nodes will be automatically increased or updated to the minimum requirement for a replica set. Also, I could provision a sharded cluster. Now in sharded cluster, we have provided two configuration options here. One is for your development need, you just need to provision, have the sharding available as you are doing the testing. So there will be a single query router and a single config server and the data nodes available there. Or you could always choose a production configuration, so where now the number of nodes is increased to 9, so it will be provisioning like 3 data nodes, 3 config servers, and 3 query routers into the appropriate sharding configuration. Once the shard is added, you could always grow that further from there as you're running into the configuration there. So let's say I'm going to provision a sharded cluster here. I'm going to go and say select my EC2 cloud. Same thing for the zone, instance size like we saw on the other side, access group. Then provide some information about what you need. When I selected the shard, I provide a automatically hash on the thing, or I wanted to provide a shard key and so on. So I could select that. I could say go next. Similarly, provide my storage information. I want to start with the 10 GB of storage and select a parameter group if it's available. If not, just leave it alone. Click on submit and gives me summary information. I can click on that and it will start provisioning that database. So I'm going to go cancel from here. Let's go look at the existing database which is provisioned. Similarly here as well. So the configuration you choose will be based on your application requirement. So you could choose a standalone node just for your development basic testing. You could choose a replica set to get you a high availability and data durability, and then sharding provides you the scalability so that you could grow as your application grows from there. Similarly, monitoring, parameter group, access group, all the functionality is available here. In the access details, you would get the access information, the username, password, and so on. Snapshot, similar backup functionality is available. In the actions, you would be able to add more nodes to it. You could clone this instance, you could restart, terminate, and so on. Similar functionality is available for Couchbase as well. As you see, you can provision. During provisioning, you could select the Couchbase engine and provision a Couchbase cluster and add more nodes to it, capacity, and so on. Both of these will provide you the, both the services have the similar monitoring, the parameter group, access group functions. Now, Cumulogic would automatically, as part of the deployment, will provision these databases with the monitoring agent and the health agent deployed on it and collecting the monitoring status. If any of that were to go down, whether the service goes down or the virtual machine in the underlying infrastructure has some problem, Cumulogic would automatically detect those things without you having to worry about it. You'll get notified on the, your users will get notified on the email, and automatic recovery will kick in to start that. I think we are almost out of time here. I'm going to hand it back to Jack for opening for question and answers. Jack, back to you.
Thank you, Sandeep. Most appreciated. We do have some questions that came in. I do want to remind the participants that any questions you have, you may submit through the questions panel on GoToWebinar. But we do have some that are submitted. I thank you for those. Chip, first question: what approach is Cumulogic taking to multi-tenancy in the platform?
Great question, especially for service providers. This is important. The answer is largely going to depend upon how your infrastructure is configured. So the infrastructure as a service layer. Cumulogic relies on the infrastructure as a service layer for a lot of the multi-tenancy that's part of the environment. And the way that we do that is that as we interact with that underlying infrastructure as a service side, what we're actually doing is we're operating on behalf of the user within the IaaS. And so what we'll do is we would work with you to make sure that there's an account synchronization between our controller and your infrastructure as a service stack, so that our controller for each user request is able to operate as that user within the underlying platform. Now, if that's not the desired deployment scenario, the other way that we enable multi-tenancy is that we can either work with an infrastructure pool. Again, could be pre-provisioned, or it could be that we're working with an IaaS environment, but we're using the same API credentials for all database deployments. The way we deal with multi-tenancy there is that we're maintaining the firewall access, so the network access controls between the instances. And that's part of what Sandeep showed when he pointed out the access groups. So we were absolutely designed with multi-tenancy in mind for service providers. Most commonly, we'll take advantage of what the underlying infrastructure as a service platform is able to do for network level multi-tenancy, and in some other scenarios we can work with pure kind of network isolation.
Wonderful, thank you, Chip. Another question has been submitted. What are the infrastructure requirements to make this solution work?
Well, we listed a large number of the options, and the way that we think about this, again, is to look at the infrastructure as a service platforms that we support, and then think of everything else as pre-provisioned systems. And so on the IaaS side, we support any platform, whether it's a public cloud or a private cloud environment running software that you control. We support anything that provides us with the OpenStack APIs. We support Amazon's EC2 APIs, and so that means Eucalyptus environments are supported for on-prem. We support the vCloud APIs. We also support the Cloud Stack or Citrix Cloud Platform APIs. Now, that's on the infrastructure as a service side, but we can also work with really any other infrastructure environment, and we do that by asking for the provisioning of a very straightforward operating system install that usually we use CentOS, with a couple of specific configurations that need to be made. And these systems, virtual machine or bare metal servers, just simply need to be accessible via the network from our controller, and we need to have the appropriate credentials to log in and take control of the system. And so that means you can really have any type of infrastructure on the back end, and we'll use these systems as allocatable units of capacity. And so for each node, we'll push the appropriate software to one or more of these virtual machines in order to create the clusters.
Thank you, Chip. Participants, please continue to submit your questions on the questions pane on GoToWebinar. We thank you for submitting these. Chip, a couple of more. You said that you support other types of databases in the intro. Could you please review for us the databases supported and what your future plans for additional database support is?
Absolutely. So on the relational side, it's MySQL and Percona today. We'll be adding support for Microsoft SQL Server as well as Oracle. On the NoSQL side, we support MongoDB as well as Couchbase, and we'll be working towards adding Cassandra support in the future.
Thank you, Chip. Last question, I believe. While you're answering, I will check the questions pane one more time. Can you please explain how backups work and where snapshots are stored?
So the backups are specific to the particular engine. So in case of MySQL, for example, we use the native MySQL dump to store that. Now the backup is taken temporarily and saved on the local instance, and then it is uploaded from there into the object storage or NFS mounted file system storage provided on the controller. So as part of the your service provider for management of the controller, as part of the setup, you can specify if you have object storage access available, or if you have NFS mounted file system, you configure that, and when a snapshot is taken for a particular database, it will be uploaded into that space and used from there for the restore. Similarly, for Mongo and Couchbase, we do that, Mongo dump and similar tools for taking the backup of the instance. We are actively investigating the making use of the file system snapshots for the large databases, where it would just improve the performance for the backup, and it would not lock that database for a longer time for larger databases.
Thank you, Sandeep. Appreciate that. That does conclude all of our questions, so I want to thank everyone again for joining us. As a reminder, you will receive an email with the link of today's presentation within 24 hours. Also, we'd love to have the opportunity to connect with you, and if you'd like to connect with us and keep this conversation going beyond today's event, feel free to reach out to us anytime via email at info@cumologic.com, or as it notes here, the last slide, if you're interested in trying our software, you can find that at cumologic.com/sandbox, but feel free also to send us an email request stating that you would like to have access to the sandbox. On behalf of our presenters and everyone here at Cumologic, again, we thank you. We hope you have a great day or evening, depending upon what part of the world you're in. Thank you, and goodbye.
Thank you all.